Okay, so we're trying to use optics here on platforms, on silicon platforms, which are used in the semiconductor, the electronics industry. As Mike mentioned, trying to create new materials that can support optics and electronics on the same chip. And when I talk about chip, what is a chip? I mean, if you open up your computer, your camera, what you probably see is this, right? And this is just a bunch of integrated circuits, some boards, some connections, etc. And if you look at these black parts here, these are called integrated circuits, right? And what you have inside here, so this is based on silicon or some other semiconductors. Starts with silicon. You can add different materials, but mostly done in silicon. And what you have in here is small transistors, small devices that are again built at the nano scale. Tens of nanometers are normally the dimensions for these small transistors, right? And this can be prototyped in this clean room, okay? Of course, here we're talking about nanotechnology with the application, again, in the semiconductor industry. But what we do here and what we want this clean room to be, we want it to be flexible enough to allow us to do semiconductor devices, to do photonics, to do novel solar cells, to do water membranes for water filtration, for water desalination, etc., etc.
So you mentioned multi-junction solar cells. Do you have anybody at the moment working on research with multi-junction?
Yes, we have faculty working on solar cells, and he's specifically working on multi-junction solar cells. That's not myself, it's another faculty.
Do you know, it's from the Masdar Institute, yeah?
Yeah, it's a Masdar Institute. I can give you the contacts if you want.
Great. Yeah.
And the material here is again silicon. And as Mike mentioned, we're able to grow very thin layers on top of this silicon layer to build novel devices for whatever applications we want. Okay? And the way I see, the fabrication process of any device using a clean room is the same way I see a photograph. If you take a photograph in the old days, you have the negative of a photograph. You would take that photo, put it in an enlarger, expose a piece of paper that would then be sensitive to light. You would go and develop it, etc. What we do here is pretty similar. We start with normally a silicon substrate. We can grow different layers on top of it. We can then, if we have a we have a specific design, we can actually transfer that design into our wafer. Then we go into the chemicals and we develop it just like a photo. The difference is that you're building devices that are really, really